All right, team, welcome to this technical briefing. What we're looking at today is a blueprint for what could be the ultimate weapon, a system for thought injection. We're going to deconstruct the entire system architecture piece by piece. So this is our mission statement, our top-level requirement. It comes from the system's architect, Dr. John Norcine, and right away, it tells you everything you need to know. The operational domain isn't land, sea, or air. It's the human mind. Okay, here's how we'll break this down. We're going to treat this like any engineering project review. First, the mandate. What's the goal? Then, the data structure for a thought. After that, the I/O interface to the brain, the control logic that automates it all, and finally, the quantum-level endgame. First up, the mandate. Every engineering project starts with a clear requirement, right? Well, Norcine's was about as clear and as ambitious as it gets. So who's the mind behind this? Dr. John Norcine. While he was at Lockheed Martin back in the 90s, he was working on some deeply classified projects. And what he was really trying to do was move past conventional warfare entirely. His goal was to treat the brain as the next battlefield, an environment you could map, access, and ultimately control. Okay, section 2. This is critical for any system we build. To engineer a thought, you first have to define it as data. I mean, if you can't measure it, you can't manipulate it. Simple as that. So let's look at the fundamental data structure they came up with. Norcine called the fundamental data type a semiotic. And this right here was the key breakthrough. It's the step that turns something totally abstract, like an idea or an impulse, into a single machine-readable data point. It's the bit of thought. So how did he structure this data? He used something called Pearson logic. It basically models a thought as a relationship between three things. The object, the actual thing, the representamen, which is the symbol for it, like the word tree, and the interpretant, which is the effect it has on you. And here's the kicker. This triadic structure gives you the variables you need to map it mathematically. It makes a thought computable. All right, so we have our data type. What's next? We need an I/O system, right? A way to read from and write to the brain. This is the hardware and software layer, the bridge between our digital processor and the biological wetware. Norcine called this I/O system Biofusion. And if you're familiar with the military concept of sensor fusion, combining data from different sensors to get a clearer picture, well, this is that, but for the brain. Think of it as creating this complete, real-time, multi-layered diagnostic of the brain's electromagnetic state. And this is where it gets really practical. The process itself is a simple 4-step loop, something any engineer would recognize. Step 1 is the read operation. Step 2 is mapping that data to a specific location. Step 3 is the write operation. And Step 4 just defines the functions that write operation can perform. It's a standard read, process, write cycle. Okay, so this is the absolute core of the injection mechanism, the magic, if you will. The theory is that a thought is just a biological function, which means it can be represented by a really complex mathematical equation. So, if you can calculate the inverse of that equation and transmit it back to the brain, you can fool the neural circuits into processing it as a real, organic thought. That's it. That's the fundamental principle. All right, we've got our data structure and our I/O. The final piece of the puzzle is the control system. How do we automate this whole thing and turn it from a simple interface into a fully autonomous weapon? The underlying doctrine here is called reflexive control, which has been around in info warfare for a long time. But Norcine's goal? Take the human out of the loop, completely. Build an AI that could run these operations at machine speed without any human intervention. And this diagram from his colleague E.T. Nozawa, man, it just lays it all out. This is a classic closed-loop management system. It senses the environment, processes the data, exerts control, and takes action. It is a complete, self-contained model for autonomous combat. So let's drill down into that warrior block. What is it? It's a semiotic agent, which is basically an AI running on a simple negative feedback loop. It looks at the current state of the world, its beliefs, and compares that to its programmed goal, its desires. Then it just takes whatever action is necessary to minimize the difference between the two. And of course, this whole thing is built for a fight. It's a constant looping process. You model your opponent, you predict what they're going to do based on their preferences, and then you calculate the best reflexive decision to exploit those predictions and win. It's pure automated strategy. And you might be thinking, this is all just theory, right? Well, not exactly. Check out these slides from Saab Microwave Systems from the early 2000s. They show a clear roadmap, moving from systems with a human in the loop to a vision for 2020 where almost every layer of information processing is fully autonomous. And the applications, they go way beyond the battlefield. The same core technology, a direct brain-computer interface for reading and writing signals, could be used for something like this, envisioned by researchers at Sandia Labs. The control principle is exactly the same. All right, final section, we've seen the system architecture. Now let's look at the game end, where this technology could ultimately go. We're not just talking biological anymore. We're talking about the quantum level. This is the really forward-looking stuff. Norcín's big idea here was something he called quantum shift keying, or QSK. If you think in networking terms, this is the physical layer, the actual wire. The theory is that you can encode information directly onto the quantum structures inside neurons, the microtubules, by messing with their quantum state. This model, it's pretty out there, I know, but the implication from an engineering standpoint, it's a game changer. It means non-local coherence. And what that means is a system that could influence brain activity instantaneously, totally unbound by the laws of classical physics or signal travel time. We're talking about a zero-latency weapon. You know, Norcín actually made a pretty chilling prediction way back in 2002. He basically foresaw a future of border semiotic wars, all driven by perception management and the use of pre-positioned neuroweapons, just like the one we've been reviewing. So that brings us to the final question on the table. This whole blueprint is over 2 decades old. We know there's a huge gap, maybe 15 to 20 years, between classified research and what the public sees. So you have to ask yourself, how much of this system has already moved from the drawing board to deployment?